Hi, everybody. We are here today with Brenna Biggs from NASA's Airborne Science Program, helping us launch our podcast today. Brenna, welcome. You're our first guest, and we're super excited to have you.
Thank you so much, Audrey. It's a pleasure to be here with you today, and I'm super excited to talk some cool science. Thank you for having me.
Yeah, of course. Could we start off by just learning more about what the Airborne Science Program is and what you actually do there?
Absolutely. So NASA, I'm sure, an acronym that a lot of us have probably heard, but we probably think of space stuff when we think of NASA. So we might think of the moon or astronauts or the rover, satellites, things like that. But NASA actually does a lot of work on planet Earth as well, because Earth is our home. We care about what happens here. We want to keep it safe. So one way that NASA does Earth science is by using airplanes, aircraft. And so the NASA Airborne Science Program has four main goals. The first goal is to do big studies about our planet. So we might go, let's say, to Asia and look at air quality. We might go to South Africa and look at biodiversity. So we can do these really big, large scale missions that way. But we also do some stuff that maybe doesn't jump out right when we say airborne science. So, for example, if we are going to send a satellite to space, we need to make sure those instruments that we're sending up there work before we spend all this money and time just putting them up into space. So, one way we do that is to test those pieces of equipment on an airplane first to make sure it's working before we send it up to space. And then, after it's up in space, we need to double check it's working by using instruments on airplanes. So, it's kind of this like full circle thing that we do to support satellite launches. We can also do new instrument development in general. So it could be things that maybe aren't going to space but still need to be tested. We can use airplanes to do that. And then finally, we also use airplanes for a lot of educational work as well. And so there's a lot of outreach opportunities. There's also a lot of internship opportunities for students that the Airborne Science Program has provided throughout the years.
That sounds really cool, and when you say, like, the outreach opportunities and the education, that just it makes so much sense to me. I figure with like you said, a lot of us think about space and astronauts and, that sort of stuff when we think about NASA, but it must be a really cool opportunity to get to be like, "Hey, look, NASA also studies the Earth," and then, I mean, what would be cooler than rolling up in a NASA plane or, like, letting students see that? I think that makes a lot of sense, and, it's really cool to learn more about what NASA's doing, not just for space science, but for Earth science.
Wonderful. Yes, I agree. I guess one point I can add on to that, Audrey, if you're open to that, is NASA for many years has had this airplane called the DC-8, which was the world's largest flying laboratory. And so you can picture all of these scientists, probably it holds between 30 and 40 people, all working on their scientific equipment, all studying either the air quality or they're looking down with their instruments or they're looking up at the sun with their instruments. There's all this different amazing science that happened on that plane. In addition to that, we had an internship program that happened for many years on that plane that invited undergraduate students to come and actually fly on the airplane as well. So that airplane just retired this year. But what's exciting is that NASA has a brand new 777 airplane, which is gigantic. It's going to be able to hold over 100 people, which means hopefully even more opportunities for students to come and join us on our science adventure in the sky.
That's super cool, and, I'm hoping the answer to this is that you fly all of the planes, but can you tell us what it is that you actually do in the Airborne Science Program?
Absolutely. So unfortunately, I'm not a pilot. My background is more of it's a scientific researcher type background. And so I do have some experience operating the instruments on the airplane. So I have been a scientific operator. I have 200 plus hours of experience on the airborne laboratory collecting information, particularly around air quality. Now, though, my work is a little bit more behind the scenes. So I have two roles at the Airborne Science Program. One is focused on outreach. And so whenever there's a large scale airborne campaign, I get to talk to students about it. And that's the part of my job that I really love. I love having scientific conversations, especially with young people that are just kind of figuring out, what they might be interested in. So that's about half of my job is all outreach focused. The other half is something called advanced planning or strategic planning, 5-year planning. And this is basically asking scientists and the scientific community what their needs are. So, in 5 to 10 years from now, what type of airplane do you think you would need? What type of science goals do you have? And then trying to document those goals, finding overlaps where there could be collaborations between different programs and scientists, and then also making sure that the Airborne Science Program can actually meet the requirements of the science community. So that's more of like talking to adults, talking to the scientists about their needs, and then the other half is talking to younger students about the program.
That sounds one, like you have so many hats that you wear. Holy cow. I have no idea how you do all of that, but I would love to know how you got interested in all of these different things, where from science to communications and all of it. So what was it that sparked your interest in all of this?
Thank you for that question. When I started as an undergrad, I got my undergraduate degree in chemistry, but I started as a communications major. And I was very interested in communicating. And back then it was advertising. Like I was very interested in making commercials of all things, like being behind the scenes there. And then as I went through the first year of college, it just didn't feel right. Like I noticed that all of the general education classes I was choosing were all STEM, like, even though I was supposed to be focused on comms, I was like, "Oh, but this math class sounds really cool," or "This physics class sounds cool." So, once I realized, "Oh, actually, I think I'm more interested in the science part of it," and it wasn't until I started working on my PhD that I realized there's this really important overlap between communications and between science. So that's kind of it took me a while to kind of figure out where I would fit in, but it started with the alluring challenge of chemistry. I will also say as a kid, I was very into fantasy books. I like Harry Potter, Lord of the Rings. Like I grew up with all of that content. And I found that the closest thing to magic that we have in our world is chemistry. And so I was very drawn to that part of it as well. It's like, oh, all these amazing color changes and reactions and form changes, matter changes. All of that is very exciting to me. And so I was attracted, I guess, to the challenge and to the fact that it felt so close to that magic that I really liked in my fantasy books.
That is probably one of the most interesting ways I have heard our like pop culture, sci-fi kind of stuff be wrapped back into what we actually do in science. That's super cool. I have to go
Cool.
rewatch all of the Harry Potters because I definitely did not focus on the chemistry in that.
I recommend.
But as like a little follow-up question, you were talking a little about the degrees you have. Have you ever been interested in going back for communications?
That's super interesting. So I guess one thing that I really interests me on top of science is I'm very interested in language. Like I'm interested in how languages develop and die and come back. And I find that all very fascinating too. So I think if I were to go back and try to go for another degree, it might be communication adjacent, but it wouldn't be communications exactly. It would probably be something related to language in the way that we communicate because I find that very fascinating.
That's super cool. Yeah.
Thank you.
It brings up an interesting point how you brought up like fantasy related to chemistry and everything. I've also been informed that you like to play video games as well and everything during your spare time and everything. Was there anything else non-related including video games, that kind of like got you into chemistry as well? I mean, because it's funny how that kind of correlates, right? You see something
Yeah.
on pop culture and then it kind of like pushes you towards like an interest within another field and everything. So was there anything that can correlate with that between the two and stuff?
Great question. Yeah, video games are definitely a big part of my life still. I still enjoy playing video games in my spare time. I will say, when you asked that question, a few things kind of came to mind. The first is I've always liked puzzles. Like, I like jigsaw puzzles a lot. I have actually a puzzle subscription service that just keeps sending me puzzles, so I can always have a puzzle to do. So I think that's always been a part of how my brain works. I like a challenge and I like being able to solve something. So I think that naturally kind of pushed me to science. In terms of pop culture, I don't want to say growing up, but like when I was entering college, so late teenage years was when Big Bang Theory and Breaking Bad were super popular. And I was very into those shows. just because it was exciting. Like I felt like I was always learning something new. I was very interested in, how they were able to make something out of something else. And I think that also kind of pushed me like, this is okay to be interested in this topic because the rest of the world is now like, oh, science is cool. Because when I was growing up, it wasn't necessarily cool to be, nerdy and into science, but I feel like pop culture kind of changed a little bit where it's like, oh, it's cool now to like that sort of thing. So that was a good push as well.
I'm surprised you haven't said like the Magic School Bus or anything like that and stuff, like any kind of like cartoons, everything. Because
Yeah.
even in like shows like with their like PBS Kids programs or even like
Mhm.
Nickelodeon, what sometimes like push narrative. Some of them would like accidentally push narrative and stuff. But I'm surprised you didn't say anything of like regards to that too, like cartoon
Mhm.
shows or anything like that and stuff, or Honey I Shrunk the Kids, or things of that
No,
nature and
I feel
stuff.
like I was into SpongeBob, which I'm having trouble tying to science. So, yeah, I'm sure there are connections. I do remember liking Magic School Bus a lot, but there were a lot of shows that I liked just because they were silly, not because they had any sort of scientific merit. But yeah, I love that there are so many shows. Like even now, there's shows like Doc McStuffins. Like there's all these shows for kids now that I didn't have when I was a kid that I think are really lovely. I remember enjoying Bob the Builder from like an engineering perspective. I thought that was kind of a good one. But yeah, I love that you brought that up. It's fascinating.
Yeah, it's kind of I can picture the like little Brenna watching these movies and playing these games and like you get to college and you change your path and then you're watching Breaking Bad and you're thinking about what you're gonna do next. So I now we know that you're now at NASA. So going from sort of, yeah, like that little Brenna all the way through college, and I know you got your PhD also. Did you see yourself taking these interests and these skills to NASA? And yeah, what was it like for you getting there? Was it hard to end up there? And have you always been doing what you're doing there? Did you start off somewhere else and kind of move through the agency?
Really good question. So let me think of the best way to answer. I feel like a lot of getting your dream job ends up being kind of a who you know scenario. And I know that's really hard. I myself am very introverted. And so it's very hard to think about networking as being this really important skill. But it's really important to make connections with people. And so I will say I'm so fortunate to have known the right people at the right time and express, hey, I'm interested in this at the right time to the right people to get me where I am. So I can talk through a little bit about, what that looked like. I graduated with my PhD in chemistry in 2021. So you can imagine that was still during the pandemic. Things were a little hard. It was tough to find a job. So I wasn't sure what I was going to do. And what I ended up doing was I made a spreadsheet because I'm a scientist. I made a spreadsheet of all the people that I know and how I might be able to reach out to them for help. So it was like, here's this person, they do this. How could that tie into something I'm interested in? And I tied that to inviting those people to my dissertation. So it didn't look like I was just, hey, please help me. I don't know what I'm doing. It was like, hey, just so you know, I'm graduating. You're invited to come listen virtually to my dissertation. And then I will need a job. Here are the things that I'm interested in. And that actually gained me a position at UCI, UC Irvine, which is where my alma mater was, in the sustainability office. It was like a 6-month contractor program that they created for me specifically because I asked for it, which is absolutely amazing. While I was in that position, a mentor that I had from a few years prior to that announced that she was leaving her position with NASA. And in doing that, she reached out to me and said, hey, I saw your email that you sent me, and I think you would be a really great fit for this position. Think about it. And they have to release the positions publicly, but she really encouraged me to apply for her position. And that was kind of my foot into NASA. So during my graduate program, I had done a lot of work with them previously. And one of the jobs that I had was I was a mentor for the NASA Airborne Science Program's SARP program, which is Student Airborne Research Program. So I had worked with NASA a little bit already in my laboratory setting as a graduate student, and then the leader of the SARP program was the one who was leaving. So it just worked out where I was able to fill her role as she was stepping out of that role. I was in that role for about a year, and then decided that I wanted to pursue more of a communications behind the scenes route, which is why I am in the role that I am today. So it was kind of a little bit of hopping around to find the right position, but it definitely started because I knew the right people. So I encourage young people, keep those connections that you have with your friends at school right now. Keep those connections you might have with your teachers, your professors, and not in a fake way. I mean, in a genuine way. Like, make friends with people around you, because it can be very helpful down the line when you need a sounding board, a recommendation, or somewhere to work.
Yeah, and I really like that you mentioned the making friends and making connections. I think it can be really daunting to look at networking and to think of it as like this. I always saw it as kind of this weird social thing that we do, and it's like asking people for favors. But I don't know. I felt weird about it until somebody explained it to me as like it's people who you've made a good impression on, who have an interest in you and in your success, and it's not a one-way street either. I think it can be really cool. Like you said, you had this mentor and she clearly saw some value in you. You must have contributed to that mentorship in a way where whenever this opportunity opened up, she thought of you. So I think it's a really good reminder to people out there to think of networking as a relationship more than this, weird thing that we do to try and get jobs or ask people for things. So I'm really glad that you mentioned that. And
Thank
as a
you.
fellow SARP alum myself, I was in the Student Airborne Research Program in 2016. I've sort of done the same thing, just trying to like make mental notes of people who I know who are doing cool things in cool places. And interestingly enough, that's how we ended up with you on this show today. It's a pretty big network, so it's really important tip to keep people close and be interested in what they do, and hopefully they're interested in what you do too.
Yeah, I love that you circled back to the fact that I'm on this show getting to talk to you today, because we have this network. So it does, and I must have met you, Audrey. I don't even know. It's been years now. It's been years since I've known
Yeah.
you. So it is important to keep up those connections. And it can lead to friendships in unexpected places. So yeah, seconding what you said, I agree.
Absolutely. And back on that network, I know the network, it needs to be huge. I personally have like one of my dream jobs right now because I knew the right people who were working there and I was like, "Hey, put in a good word for me," kind of thing. But it's really strange that while the network is absolutely massive, it seems like the fields are always so small. You always run into the same people. Which I think is really cool because you could all kind of learn and grow and work together. But speaking of work, not to take away from all the amazing things that you do, I absolutely love it. Um, but was there ever a time, like back in high school or even in undergraduate, where you weren't working in STEM? What other things were you doing in the meantime?
This is so funny that you asked this, because I'm going to go back to the fact that I love puzzles, and I love trying to think through a challenge. So for 5 years, this was like between I started between when I wrapped up my undergrad and before I started graduate school, and then I was still working there through grad school. So it was a 5-year endeavor at a rock climbing gym. So I love rock climbing because of the puzzle, because you're looking at this route and you're looking at how can I get myself up there. And my body, not to be too much information, I have very short arms. So to look at something that was set by someone with normal arms and then go, how can I get myself up there? That was really fun. Like, it's just fun to try to solve this problem. And so that was the reason why I really like to work there. Another reason why I think it's important for people to show up in spaces that maybe they're underrepresented. And so rock climbing is a traditionally very masculine field. And so I thought it was kind of fun. I was the only girl working at the gym, and I was also the manager. So it was kind of fun to have, this role that was also hopefully inspiring to fellow female climbers. And I feel that way about STEM as well. I feel like, traditionally a lot of women have been underrepresented, and it's nice to be able to show up and take up space in those places. So rock climbing was my weird job for 5 years, and the only reason I stopped was because the pandemic closed the gym, which is really sad. But I loved working there. It was fun.
That is super interesting because when you brought back up the puzzles, my brain immediately went to she worked at an escape room. I think working at an escape room would be so much fun because I also love the puzzles. But to bring it into rock climbing, just a different sport kind of outside of STEM is super cool.
Thank you. It's so funny that you say that. My brother's birthday was this week, and I'm designing basically an escape room in my house for him. So when he comes over this weekend, he's gonna have to like find all of his gifts, and I have riddles and all this stuff. So yeah, I'm I
Oh my
definitely
god,
love a good puzzle.
my birthday's in February. Can you do that for me? No problem. See, make
She's
a
in your
network.
network now.
Yeah,
Yes, yeah, we're in the same network. I got you.
perfect.
It's absolutely funny that you bring up that your job originally at college was the gym because my job when I was in college was the gym also and in grad school and now. But you can't get rid of fitness. Fitness is
Nope.
a lifestyle that you just, no matter what you do or where you go, it's always going to be a part of you and everything stuff. So, but um, you mentioned previously in regards to like internships and abilities for like young people to get involved some way, shape, and form. Is there anything new that's coming out within the program that they should be looking out for? And where could they find it and everything too?
Yeah, great question. What I would encourage young people to do, we have internships starting from 16 years old. So if you're 16 and up, they're open. So I would encourage you to type in NASA internships and just look down there, see what you might be interested in doing. Sometimes as you get a little bit older, sometimes they're paid experiences too, or maybe they pay for your housing for you to come live in an area for a few months. There's lots of different amazing opportunities, and I think even if you do it and you didn't like it, that's still super valuable because then you determine something you didn't like and you can kind of rule it out and move on to the next thing. So there's never a bad opportunity. I think all opportunities are good sources for us to grow. So that would be where I would start. In terms of things to look out for, I know Audrey and I had mentioned the SARP program a few times. So that's more for undergraduate. So if you're nearing the end of your undergraduate experience, that could be a program, SARP. I would maybe look into that as well. And then another program I can talk about is the GLOBE program, GLOBE like the planet. They are a citizen science program. So all you really need is to be in a country that has an agreement with the GLOBE program, which is over 100 countries. The US is one of them. There's many countries around the world that are already part of the program. And if you're in a country that's part of it, you are able to collect your own scientific data using a predetermined standard method. You then upload your data to the website and you have access to look at everybody's data. So if I'm in the United States, I live in California, I can look at data that a Filipino student took about clouds earlier today, or I can look at trees in South Africa that somebody took pictures of. So I'm able to see data from all around the world, and I think that's a really cool way to get involved. It's also kind of cool to do in a classroom setting. So if you have a teacher that might be interested in that, you can always bring it up to them too and tell them about this cool program. A lot of the work can be done using your cell phone too. So cell phones are so advanced these days. It's easy just to take pictures of things, take pictures of clouds, trees, and real scientists will use those data to double check that satellites are working or to complement campaigns that they're doing. So that can be a really cool way to get involved with the community and see, what types of data do you like to collect? Do you even like collecting data? Do you want to be a researcher? And then the last little bit I'll throw in there. I'm not super familiar with coding. I don't have to do a lot of coding for my job, but I will say that there's a program called ARSET, ARSET. And RSET offers a lot of training opportunities specifically related to coding. So if there's a NASA campaign that has a big data set coming out, you want to learn how to use it, whether it's for a class project or just because you're curious, RSET will offer trainings about how to use those data. So that can be another cool way to get involved with NASA as well. So all of these are NASA related programs that might be of interest.
I'm really glad that you mentioned regards to training because I know
Mhm.
that one thing is that preparation is key to like leading into like programs or even bigger opportunities and everything. Um, what would you suggest, when they're applying for these, programs like internships and it's like that, what we suggest like they should get prepared for? Like what are their requirements, when it comes to these programs and everything?
The one thing I'll say is that a lot of these programs actually value having little experience. So it's like we want to use these opportunities to train the future. And it's okay if you're coming in from, let's say, a small rural school that maybe doesn't even have the major that you want. It's okay to come from those types of places. So we have we have a lot of successful students. I'm thinking a lot, Audrey, about the SARP program. We've had a lot of really successful students come through that program that come from places where they've never done research, or maybe they've never even thought about coding, they've never collected data. And that doesn't make them bad students or bad researchers. It just means they haven't been given the opportunity yet. So these internships are ways that students can get those opportunities that maybe they don't have through their school. And I think that that's an amazing opportunity. So yeah, it's some of the things you're right is they need a little bit more, specific skills, but a lot of the internships don't require much to come into it, and that's kind of the point. It's like we want to give students a chance to feel out if they even like science in a new opportunistic way.
That's really exciting to hear, Brenna. Thanks for sharing all of those resources that NASA has. And speaking from personal experience, I know she mentioned a lot, and there's a lot out there. I found the NASA Student Airborne Research Program, by literally Googling NASA internships because I thought NASA was cool and I wanted to do something with them. And like Brenna said, I didn't have like that sort of experience necessarily, but quick Google search, application, all of that stuff is a great way to start. I know it can be pretty intimidating, but Brenna shared a ton of cool resources for getting into NASA, getting your foot in the door in a way, starting to build your network perhaps. And thanks again, Brenna, for sharing that.
My pleasure. And one more thing that just came up to me, even though we don't require a lot of experience, one thing that a lot of folks will do, and I only know this because I was selecting students for SARP for 2 years, so I've read through applications and I know what folks are looking for. One thing I'll add for a lot of these internships, they want good letters of recommendation. So this circles back to what we were saying about networks. Make sure you have a good relationship with your professors, with your teachers, because it does come back. Those relationships will continue to come back. I still have students reaching out to me for letters, and it's been a few years since I was in charge of the program. So those relationships don't go away unless you want them to. So I encourage you to keep up the relationships that might benefit you in the future.
Yeah, I can only imagine how important that is. And when it comes to building networks, I know it's really easy to, build a network with the people that you're with locally. They're
Mhm.
in the office with you. They're pertinent to the position that you're in or the work that you're doing. So, as somebody that's gotten really lucky with being able to travel and go to conferences, do you get to do that as part of your communications position?
I do, absolutely. So I will say I've been to DC twice the last month and I'm going back in 2 weeks. So that's like one example of I keep having, to go to different places. There's a lot of travel involved. I was in Asia for 2 months earlier this year. I was out of the country, just gone doing outreach. There's a lot of really incredible opportunities to travel. I did New Mexico earlier this year. So it's you get to go all over the place, which is amazing. The travel is funded, it's covered. I also get to pick my own hotel, which means I get hotel points. Like it's there's all these benefits to that. And my job does require a lot of travel, which can be exhausting, but it's worth it. And that's kind of there's two parts to that. The first, because I have so many hats, right? So the first part of that is that I travel a lot for outreach. So for Asia, I was supporting the Asia AQ mission. So we traveled to different countries around Asia collecting air quality samples. And that was actually the final mission of the DC-8 airplane that I mentioned earlier. So that was a chance for me to go physically to those countries and interact with students in those countries to tell them about what the mission was. And then I also had them help us collect the data for the mission as well. So it was kind of this exchange that we had with students there, which was amazing. The trips to DC are to meet with folks at NASA headquarters. So there's kind of like you have chances to interact with students and young people about science, and then I also get to travel to interact with the adults about science as well.
That, I mean, it sounds amazing. Like you literally get paid to know the science and then travel around the world and tell people about it.
That's it. Yep. It's amazing. It's a dream job.
Just asked, just answer my question anyway. And start, traveling, hotel, everything's paid for the most part. That's why I wave my hands like this because I'm just like, man, do you know how much money I have to spend alone just to travel from like here to possibly LA every once in a while? It's ridiculous. It's nuts and everything. Hopefully I get to first class one day. Probably when I'm like 59, but like we can make our promises one day. I was going to ask you pretty much answer anyway, but even then it's just like, what is like your favorite part of your job? Is it the traveling? Is it the connecting with people as far as just like learning about what you do or like discovering new things, what you do, and just learning different things within STEM and science and everything? Like, what is your favorite part of your job? Or is it flying planes,
Wow.
which you probably do? 'Cause
I love the question. I feel like there's so many aspects of my job that I love. I love getting to keep up with new science. So you're right in that I have to really understand a mission. I have to understand all of it before I'm able to talk to people about it. So that's one thing I love is that I still feel like I'm learning, even though I'm out of school. I'm always learning something new. And then the other part that I love is getting to share that knowledge and talk to kids. Like I love getting to talk to young people about science. And when I say kids, this is like K through 12. So we're talking, people that are 3 years old up to people that are 18 years old. It's a big range of folks, but everybody I think we're all born scientists. And then sometimes that just gets kind of squashed out of us, but we're all curious people. We're all born very curious. And so I like to foster that curiosity. And another part of that too, I always try to bring special guests that might resonate with the students I'm talking to. So, for example, when I was visiting the Philippines, one of our scientists, she's also a SARP alum. Actually, she has her PhD now, but she is half Filipino, half American. So I actually took her with me to the Filipino schools, and she would speak to them in Tagalog in their language, so that they see like this is someone from my country that looks like me that does what I want to do. And I think that that's really powerful to see yourself in somebody that you look up to. And she was wearing her flight suit. She looked all snazzy. So it's really cool to see the kids' faces light up when you're able to connect with them. I also had an experience recently where I was talking, it was again to Filipino students, and this was a virtual experience for the recent PACE mission, which occurred in September. But we were chatting, and there was a moment where all their faces, like all of them made this like face. And so I messaged the teacher after and said, what happened there? And the teacher told me that they thought I was AI. They didn't believe that somebody from NASA would come and actually talk to them about science. And when we got to the question and answer part, they realized, oh my gosh, she's actually here. Like she's not a robot. It's not pre-recorded. She actually wants to talk to me about science. So I think having those interactions are so important and valuable, especially for young people to see like, oh, this person can do it. I can do it. So I think that's the other part I love is just seeing like the lights, like, oh my gosh, this could be me. So I love that part too.
And you mentioned one final comment I want to say too is that you mentioned a big one, which was representation and stuff like having someone who looks like you or possibly even act like you and everything can be very, very inspiring, especially if depending on their background or where they came from,
Mhm.
believing that, because where they come from, they don't believe it actually is possible for them to do it.
That's a really good point, Cam. And I hope it's important. I hope it's something that our younger audience takes away too. But I'll just mention that, I mean, I'm inspired even here, sitting here today, listening to Brenna talk about all this really cool stuff. I share a lot of Brenna's interests. So it's really, like you said, I think those sometimes our dreams and that natural curiosity gets squashed out of us a little bit. Even as adults, we sort of start to settle into what we're doing. So
Mhm.
it's really cool getting to hear from you about all of these really exciting directions your interests and your career have taken you in. And one of the things I want to come back to is all of that travel that you mentioned. I think probably a lot of our audience, maybe not everyone, but we might know what it's like to be in a plane, to fly and to get to go somewhere new. But how would you compare that to flying in a lab? You described the DC-8 and those planes as flying labs. Can you talk a little bit more about what that's been like for you?
Absolutely. Wow, yes, it is way different. So I want the listeners to picture if you've seen an airplane in person, or maybe just think about what you think the inside of an airplane might look like if you've seen one in a show on TV or a movie. Maybe you're picturing rows of seats and there's like a first class, a business class, economy. Maybe you're picturing the overhead compartments with luggage. You're picturing the person coming around with snacks and drinks, maybe a little TV. So that's completely different than what we do here. So what I can give you a little glimpse of what a scientific lab looks like. We basically start by ripping out all the seats. So think of an airplane completely empty, remove all the seats. Then sprinkle in some giant metal boxes that contain scientific equipment. Some of those boxes are looking directly out of the bottom of the plane. So we've cut holes in the plane and they're looking down out into the atmosphere or the ground. We also have specialized tubes on the windows that some of these pieces of equipment can hook up to so that they can pull in air from outside the airplane as we fly around. We have all these different boxes. Once we've set up the boxes, we then sprinkle back in some of the chairs so people have places to sit. Okay, so there's no first class, there's no economy, everybody's equal, and you're just basically sitting by whatever your equipment is. And then the other thing I want you to picture is a ton of tablets, cell phones, laptops, any way that you can connect to a screen. There's a ton of screens, not because we're all watching movies, but because we need to monitor what we're doing. So as the plane flies over, my job when I used to work on the DC-8 was I would wait for us to be at a specific altitude. I would wait for other people to tell me, hey, this looks really interesting here. We're flying over a dairy farm or cars. And then I would start to collect my air sample. So a lot of it is communication. You're relying on other people in the plane to tell you when you need to do your sample. It can also be collecting the sample itself. A lot of people are collecting things. And then finally, there's also some people, all they have to do is turn on their equipment and then they just wait. So there's kind of a variety of activity. Like I was doing the weirdest yoga positions, trying to analyze my samples and collect everything. Some people are just chilling in their chairs and they're just letting their instrument do their thing. So there's a wide variety of activity happening. The other thing I'll have you picture is that everybody's wearing headsets because one, it's super, super loud on this airplane, much louder than a regular commercial airliner. And the other reason is we need to be able to talk to each other. So if I'm sitting in row 33 and someone up at row 16 needs to tell me something, they can hop on their headset and say, hey, Brenna, I'm seeing this. Can you start sampling now because it looks interesting? So it's another way to communicate by using those headsets. So yeah, it's very, very different. And then in terms of, you might be wondering, what do we eat? What kind of food, snacks, whatever. Nobody is handing out snacks. You can bring whatever type of food you want on board. So if you enjoy, I don't know, peanut butter and jelly sandwich for lunch, you can bring that. People tend not to bring things that are super messy. So for example, somebody brought curry one time and left it in the microwave and forgot, and it exploded during the flight. So you don't want to bring stuff that is going to be super messy. Normally people have, a burrito is something handheld. You bring cookies. And then finally, the last thing I'll mention, it's a little gross, but I'll tell you, these airplane flights are much different because we're not just going up to 35, 40,000 feet and hanging up there. We tend to stay low to the ground and we do a lot of up, down, up, down, up, down. And when you're staying low to the ground, it's very turbulent and it can get very, very, very hot. So imagine being in an airplane, 100 plus degrees, and it's doing this. So there's a lot of motion sickness that happens on these flights as well. And so I can say, I think the record is over 30 people vomiting on one flight.
Oh,
Or over 30 vomit bags. We don't know if they came from the same person or not. So that's the record. My record for my flight, I did throw up on one flight, and I think over 20 people threw up on that flight. So it's kind of a rite of passage. It's okay if it happens. But because of that, people tend to bring very bland food. So when we're talking about food, curry, seafood, anything strong smelling, eggs. We usually don't do any of that. It's a lot of like very bland. Here's some bread. Here's like some old pizza, like something that's going to be very bland so that it doesn't upset your stomach. So yeah, I'll share that with you as well.
that makes a lot of
Oh,
sense. And I'll applaud your storytelling capabilities because I'm feeling it. I'm picturing myself on that. Uh, not where I thought I was gonna go today, but we're there now. Uh,
You've at
how
least
many
convinced me to.
snacks?
Oh, go ahead.
Yeah. I was just gonna ask, like, how many snacks are you packing? How many meals? How are you guys up there for hours or like a whole day? How does that go?
Good question. It depends on the airplane. So airplanes have different ranges. And so some of the smaller airplanes that we have, they're only up there for maybe up to 5 to 8 hours. But the DC-8 was up there for maybe 10 hours maximum, 8 to 10 hours. That's a full workday. So that's not only a full workday on the plane, but you're usually there for a pre-flight 2 to 3 hours early. So if your flight takes off at 8 in the morning, you're there at 5 getting your instrument ready. You then have 8 to 10 hours on the plane, and then there's usually an hour or two after the plane lands that you have to take your data off. So you're looking at a really long day So I would prepare probably 3 meals to bring for that type of day. It doesn't have to be full fancy meals. I tend to do more snacks. So sandwiches, Cliff Bars, things like that, I feel like are just easy to eat. Sometimes I bring like some fresh fruit. There is a little refrigerator you can keep your stuff cold in. It's also really important to stay hydrated. For coffee drinkers, there is usually coffee on board on some of the bigger planes. So people often chip in. There's like a little tip jar if you want to add some coins or something for the little coffee fund so that people can keep refueling the coffee. That's something else. But the 777 that we just bought is going to have a much longer range. And so I can only imagine being on a plane for 15 hours. What do you bring with you for food if they're not serving meals, you know? So it's going to be a very interesting new era, I think.
That's super cool. Also, side note, I think you're convincing me to stay on the ground. I have no idea what kind of science I could do up there. I'm astrophysics. I know that there's probably some sort of stuff that could happen, but I am very happy on the
You're
ground.
happy here.
Personally,
Okay.
yes, I do. Yeah, unless I mean to be fair, I really do want to be an astronaut. So I
Ooh.
guess I'll probably have to get over the
That
turbulence
probably
and
works. Yeah.
possible growing up. But to avoid all of us doing that now, I did have another question. Was what is really the benefit of doing science in a plane? Why is that something that NASA or, other organizations even, why is that something they do?
Great question. So this goes back to why would we do stuff from space, right? So I want you to think about why would we put a satellite up in space? A satellite can see way above what we can see. So we're on the ground and our perspective is very ground level, but a satellite is going to be able to zoom way out and see a bigger picture, a bigger perspective than what we would be able to see. Similar with airplanes. So airplanes can go way up and see, we can look at how earthquakes have affected the land or how glaciers are melting or things that maybe you wouldn't be able to tell with just looking at it with your eyes. So that's one reason. The other reason is that we can get three-dimensional data. So an airplane is able to go not only side to side, but it can go up and down. And a human being can't do that as easily. Like we could drive up a mountain or something, but we don't move up and down very easily. So I think that's another really big benefit of using these airplanes is to be able to collect three-dimensional data. So for example, if I'm interested in car pollution, cars they give off pollution here on the ground, but we know that that pollution can move around. It can cross state lines, it can cross country borders or the ocean. It can also move up. So it's really interesting to fly an airplane around and see, okay, that pollution that we're seeing from Los Angeles or insert big city here, where is that moving? Where is that interacting with the urban air or with air from oil wells or dairy farms? So you're able to see these new interactions that you couldn't see from the ground. And you're also able to see them in 3D, like able to see how the air is moving up as it's traveling sideways. So that's another reason I think that's very useful to use an airplane.
That's pretty cool. Although it does kind of contradict what I know about airplanes. Are we not supposed to open the door? How do you get these air samples? How do you watch them?
I love it. Yeah, you're absolutely right. Do not open the door of the airplane. We don't want to do that ever. I will say there's kind of two ways that we get the data into our instruments. We actually three. I'll say three. One way is we can use something called a drop sonde, which means we are dropping something out of the airplane through a hole in the bottom of the airplane. So think about the cargo bay, not where we sit, but where all the stuff goes. We can actually make a hole there and it's a safe hole. It's not going to, create a crazy pressure difference or anything like that. But we're able to drop tubes out of there that can measure the air quality, can measure different things as they make their way back down to Earth. And they give us what's called a profile. So they can create a profile as they go down. So that's one way. Another way is we can cut holes in the bottom again, but this time make them into windows. So we're able to look down out of the windows and collect information that way. That's often used they're called remote sensing instruments. So it's things that don't need to touch the thing they're looking at directly in order to understand it, which is exactly what we're doing. I don't need to put my eyeball on my camera for me to see you and vice versa. We can see each other at a distance. Our noses also remote sense. I can smell food from a distance without jamming the food into my nostrils. So we have instruments that can look out the windows that way and also look out the windows that are facing up. So we can put windows wherever and have things looking out of the windows. And then finally, we can attach, they're called inlet tubes, and these are usually put on the windows. So another small hole on the window can pull air in using a pump to pump the air into the instrument directly. So the air does not interact with the inside of the airplane. It's not like you're breathing in what you're bringing in, but we can just send in whatever's pumped straight to the instrument and measure things that way too. And that's called in situ, which just means we're touching it directly, we're measuring it directly rather than remote sensing it from a distance.
It's really interesting to hear all of this stuff that goes on the flying lab. It sounds like a lot of like really cool planning, really cool tech, like a ton of logistics. And given all of this stuff that's going on up there and all of this data that's being collected and probably all these questions that are being studied, is there anything in particular that the Airborne Science Program is looking into right now, or like any new breakthroughs or new discoveries that have been coming up?
Ooh, very lovely question. I will say that a lot of our focus moving forward is on getting that 777 up in the air. So you can imagine a regular 777 airplane that was supposed to be used for commercial flights does not have a lot of the things we need to do science. And so right now we're kind of in the modification phase, which takes years. So I think that's a lot of the focus right now is on just getting that airplane ready for our first science flight, which is slated either for late 2026 or early 2027. So it's upcoming in future years. I will say that NASA has a lot of really exciting missions that it does all the time. So from an airborne science perspective, we currently are doing, we just wrapped up a mission that was looking at validating, double checking the PACE satellite, which is looking at plankton and aerosols and clouds over the ocean. So it's kind of an ocean satellite. So we just wrapped that up. We have some other missions coming up that will be looking at air quality in, I think, Mexico, the United States. We also have some looking at air quality in Asia. We often have work being done in the Arctic region. So think like up near Greenland. That's kind of a popular place that we do work. We also have some work coming up in Canada and in Alaska, especially involving like indigenous communities up there as well. So we do have a lot of stuff upcoming. I feel like there's always something going on, but I think if people are curious, my favorite like subset of missions are called the Earth Venture Suborbital missions. And so if you type in Earth Venture Suborbital NASA, then you'll get the latest grouping of those missions. So those are kind of like the really large scale multi-year airborne missions that are coming up in the next couple years or so.
Nice. That's really good to know. I think it's going to be really exciting to see sort of what comes in the next few years. And like you said, with that 777 going up, I mean, it sounds like we'll have a lot more data to learn a lot more about the planet. And I'm curious now if there's anything you can tell us about what we've learned so far, like some big takeaways, some of the important results from any of these airborne missions, or what have we learned about the Earth system, I guess.
Yeah, this is an amazing question. We've learned so much, and I feel like there's so many different, we could just have a whole other interview just on what we learned over the past few years. I will say, just highlighting some big discoveries. I know that the NASA ER2 airplane, which is one of our high flyer airplanes, that one and some other airplanes were involved in figuring out the ozone hole mystery. So this was several decades ago, but figuring out, what is causing the ozone hole. And that, of course, led to this agreement with many different countries saying we need to ban these chemicals to stop the ozone hole. So I feel like I'm hoping for more big action like that. Like I'm hoping that some of the discoveries that we're making, particularly around climate, will have an effect larger than just, oh, hey, we found this. Like I would love to see action behind what we're discovering. And so we've seen a lot of interesting things about the way pollution can move around the planet. We've also seen interesting things about how the ice is melting on our planet. So we noticed a lot of really important climate related things. And I'm hoping that in future years, we'll see some action around that. I will say it takes years to analyze these data. So it's not like, oh, we're done with the mission and we have this outcome. It can take a really long time, especially if the mission was done in another country. Our goal is not to take over their country. Our goal is to empower them to make good decisions for their country. And so all of our missions are very collaborative. It's never like we're just going in there and sampling someone and then leaving and hoping for the best. It's like we want to involve them in every step of the way so that we're equal partners the entire time. And so I'm hoping to see this international change for the better, I guess, would what I would hope the outcome to be, but I guess time will tell.
Well, that's really, really cool. You mentioned that while it's good to have the data, it's important that action is taken with that data in mind. For any listeners, for people that are concerned, for people that care, what kind of action can you advise that they take?
This is an awesome question, and it's something that I think a lot about because the answer the answer can vary based on our own privilege, I think. So, it might be easy to tell someone, stop using so much water, stop, turn off the lights, whatever. What if you don't have fresh water? What if you don't have lights? It's like, well, is it even your job to be doing anything? So I think this is a big thing that I think about a lot. And so I'll share some examples that I think about. I think we often hear common ones like recycle and again don't brush your teeth with the water on or take shorter showers. I think those are things we know already. But some things that I can say, and this is more for if you have the means and you're already doing it, I would say to limit the amount of new things you're buying. So, instead of doing fast fashion where you see something online and you're like, oh, I want it, click, I got it, right? We are all guilty of that. I myself am guilty of that. But I think just being more conscious about our spending decisions, because a lot of those things that we take for granted, that we buy quickly and that are cheap, they're made in places that are so polluted because they're supporting the economies of the rest of the world. Like if I'm buying something from the United States, it might be made in another country with people that aren't paid the proper amount, and also they're now stuck with the pollution that gets created because I'm buying something from there and millions of other people are buying something from there. So I think just being aware of where things are coming from that you're buying and how your purchase might be affecting other people, I think that part is really important. Um, this answer changes depending on where I am. So, for example, I've done a lot of work with the Philippines. They are just fantastic. Their students are so, so, so brilliant. One thing I tell them is they burn a lot of trash. So in their country, they don't do landfills, they don't do stuff like that. But I think being aware of, when you're burning the trash, where it might be in regards to someone else's house or someone else's space that they're playing in or breathing in. I think just having awareness, regardless of what country or what background you're from, I think that part is really important. And then you do what you can. I don't want anyone to feel like they need to sacrifice themselves for the sake of the climate. Like, I don't want anything dramatic like that. But I think if we all take equitable steps, then we can truly make a difference.
The question I have is connected to this is that um, what do you think, what are you curious about? Like, is there anything outside the STEM that you're curious about that, do you always think about 24/7? Or is there something within STEM that you think about 24/7 and everything? Like, what are you mostly thinking about or curious about and everything?
This is a good question. So I mentioned that I'm interested in language, and I think part of that, I love learning about language and how it's formed, but I'm also interested in how we can use it to communicate with people that might think differently from ourselves. And so that's something that I think about a lot. I have a lot of family that is politically on a different level than me, but I have to think about, how am I able to communicate my work in a way that makes sense to others and also is on a level playing field. I feel like science has become so politicized in a really interesting way, especially over the last few years. We had the pandemic, and I feel like that kicked off something new that I don't feel was part of science when I first got into it. So I think navigating that comes up in my head a lot, is like, how can I use this miracle of language to communicate what I'm trying to say in a way that is clear and non-offensive to other people. And so that's something that is it sticks with me a lot, and I find it challenging, but I love a good challenge. And so that's something that I think about quite often.
So how do we communicate? How can we communicate with each other in regards to that without like being triggering or polarizing?
Great, great question. I think it's important to approach someone that you might, you're either not sure how they feel about what you're going to talk about, or they disagree with what you're going to talk about. I think it's important to approach it with you are not trying to change their mind. So the goal of your conversation should not be to try to change their mind, because if they're already set in their mind, you're wasting your time. But I think if you still want to get your point across, which is valuable, you should be able to feel free to talk to people that have a different opinion than you. I think trying to find a way to meet them where they are is really important. So, for example, I've done a lot of work with dairy farms, and I've had dairy farmers tell me flat out that they are not emitting anything. They are. We know they are. We know their cows have methane. We know all of that. And so that's not to me, that's a fact. That's not a political issue. But trying to, approach someone that says we are not emitting anything, to try to explain to them the science behind what they're doing, that can be really challenging. So another example I'll give is a fisherman. A fisherman knows that he or she is going to know the fish. They know the water. They're going to notice if there's changes in how the seasons are playing out with their fishing schedule, right? So maybe you approach someone like that on, hey, did you notice that there was like this weird flood that caused the water to be less salty, and therefore you got this fish less than you did last year? Or maybe it was hotter this year than it was last year, and so your catch went down. Like, I think finding a way to meet someone where they are in what they know, and then using that as kind of a branch off point. When I first took like science communication classes, the first thing they tell you is to find your opening statement should be a yes statement, something that someone agrees with already, so that they're already listening and you're not turning them off by your first statement. So open with something that you can agree on, whether it's, it was hotter last year, period. It's going to be hard to find me on that if it literally was hotter last year, right? But if we then branch off of that and use that to some other way to describe whatever I'm trying to describe, I find that to be a little less polarizing. I will say it does not always work, and you might end up with some people that get upset with you, but I do think it's important to be able to feel safe to share what you believe, just like they feel like they can share what they believe. So yeah, that's something I think about a lot, is just how can we communicate better in a less polarizing and less triggering world. I haven't solved that yet. That's a huge issue, but it is something that I think about quite often. So I love the question.
Yeah, it's because it's something I think about often too. Because even
Mhm.
like my experience, whether it's grad school or just
Mhm.
things of that nature, so it's like someone who's in a field that I'm not in, but something that
Mhm.
I've observed, or something that's like practical or like informative, like that. That's something else will pop in. You're just like, hey, this happened, and what's going? You say like, what's going on, or just be like, hey, this is happening. Just leave like a statement like that. It could lead this like fearful thing within you, just it's like to even mention that because you don't want to
Mhm.
ruin their not reputation, but even sometimes like their ego and everything, I would
Mhm.
say. Because they have worked really hard to be like, professionals in their field, and you don't want to take that away from them. But you did notice something that was just like, hey, I knew we said this, but something has changed. But I mean, that's part of science, It's like you think this is it, but then it is, but then it's changed to be something totally different and everything. And stuff.
My favorite stories are of scientists like back in the day before we had the internet. When there was a mistake, they would go in front of their entire cohort and say, hey, I messed up. Like, I know I said this at the conference last month. I made a mistake. And everyone would cheer and it would be fine. And it's okay. And I wish we could do that. Like, I wish it was more okay to say you made a mistake, because I think sometimes we hide behind a shroud of an opinion that's shrinking because it's wrong, and you just want so badly for it to be true that you're willing to just like fight for it. And I think that's a problem. So yeah, I agree with you. And I do think, to your point, Cam, I think approaching that person in private is helpful. So even though back in the day scientists would do this with a huge group of people, I think nowadays people respond better to, hey, I'm your friend, you're my friend, I just wanted to share this with you, like I noticed this, right? But instead of calling them out in front of all their whole cohort of people, I feel like that one-on-one is really valuable.
I love the advice, Brenna. That's been really, I think, a good message for our audience, I hope, and for all of these aspiring scientists who are inevitably going to be met with questions that maybe they don't know how to answer, or maybe they have strong opinions on, or just find themselves in fields that tend to be a little bit more polarized, or kind of like you mentioned, more politicized. So I hope that that's helpful for people out there. I know it's definitely been helpful for me, and sort of generally the advice you've given and the insights you've given, I've personally found really inspiring today. And just want to say thank you. Thanks for being here. Thanks for chatting with us and taking all our questions and listening to all our curiosities, and for having a great discussion with all of us.
Thank you so much to the whole group. It's been an absolute pleasure getting to hang out with you today. And to the listeners, I hope something was valuable out of this. If not, chuck it. That's okay. You had an experience, but I hope that you found something that you could relate to. And I wish you all the best in your pursuit of science.